Okay, folks, it's time for your last video of the day, our advanced gravitation problem. And with this advanced problem, what we're going to do is we're going to solve the same problem with the bird, the mouse, and the sausage, but this time we're going to look at what happens when you have multiple objects acting on one another. So, let's go ahead and get started. And again, I've written our equations over here, so that way they are nice and easy to find. And again, as I read through the problem, I'm going to go ahead and just highlight my unknowns. And this time, I'm going to just use yellow for all of them. So let's get started. Our same grim fairy tale discusses the story of a mouse, a bird, and a sausage. The bird has a mass of 5 kilograms still, and is still 20 meters away from the sausage, which still has a mass of 2 kilograms. If the mouse, which has a mass of 3 kilograms, is directly between, and I'm going to go ahead, I'm not going to highlight that, but I am going to underline it, is directly between the bird and the sausage, what force will the mouse feel? And I'm going to go ahead and highlight my unknown here, my question, in red. So let's go ahead and get started. And I'm not going to start by listing out my givens because this is complex enough that drawing a picture is going to be helpful. So let's go ahead and draw our picture. So over here, we have our bird. Here, we have our sausage. And in the middle, we have our mouse. And let's go ahead. I'm going to try and draw a cute mouse for y'all. Yeah, it's a little bit cute. It's a little bit ugly. So here's our mouse. And we know that the bird has a mass of 5 kilograms. The sausage has a mass of 2 kilograms. And the mouse has a mass of 3 kilograms. We also know that our bird and our sausage are 20 meters away from each other, and the mouse is halfway between them. So that means that the distance from the bird to the mouse is 10 meters, and the distance from the mouse to the sausage is also 10 meters for a total of 20 meters between the bird and the sausage. Finally, I'm going to go ahead and draw in my arrows to represent the forces. We know that the mouse is going to be drawn towards the bird by the bird and is going to be drawn towards the sausage by the sausage. And we even can figure out which of our two arrows should be bigger because we know that this 5 kilogram bird is going to have a stronger gravitational pull than our 2 kilogram sausage. So I'm going to go ahead and draw my sausage arrow a little bit shorter. So we have the force of gravity to the left of the bird on the mouse, and we have the force of gravity to the right of the sausage on the mouse. And now we are ready to list out our givens. And really, those are all in the picture, yeah? So we know the mass of the bird, we call that the mass of the bird, capital M, is 5 kilograms. The mass of the sausage, which I'm going to go ahead and I'm just going to erase the rest of the word sausage. I'm just going to call that M sub S, and that's 2 kilograms. And finally, we know the mass of the mouse, M sub M, is 3 kilograms. We know the radius from the bird to the sausage, from the bird to the mouse is 10 meters. We know that the radius from the sausage to the mouse is also 10 meters. And that, folks, is all of our givens. And we have to know our unknown as well. And our unknown is going to be the total net force on the mouse. And so this is a couple of steps because we need to remember, I'm going to go ahead and write my equation. We know that the net force on an object is equal to the sum of all the forces acting on that object. Of course, our forces are vectors, so their directions matter. There are only 2 forces acting on our mouse, the force of gravity from the bird and the force of gravity from the sausage. So we can write the force F net on the mouse is going to equal the force of the bird on the mouse plus the force of the sausage on the mouse. However, there's one thing wrong with this equation. Our forces are vectors, and our two forces are acting in opposite directions. So, rather than adding them together, I'm going to subtract them. And to do that, I'm going to start by adding in my frame of reference. And I'm going to say that the positive x direction is to the right and the positive y direction is up, as it usually is. So, that means the net force on the mouse is going to equal the force of the bird on the mouse, which is going to be negative Fg of the bird on the mouse, because that is to the left, plus positive Fg of the sausage on the mouse, because that is acting to the right. And here is where drawing your picture matters, because again, direction is key. So we can go ahead and put in our equation. The force on the mouse is equal to negative g times the mass of the bird times the mass of the mouse divided by r squared. I'm going to call that r be bird to mouse squared, plus big G times the mass of the sausage times the mass of the bird, times the mass of the mouse, divided by the distance between them, the distance from the sausage to the mouse, squared. This is very ugly looking, but I promise it's not going to be as bad as you think it is. Let's go ahead and just plug in our numbers, because this is really fundamentally a plug and chug problem. So I have G, which I'm going to factor out and get back at the end, 6.67 times 10 to the negative 11th, times negative mass of the bird, which is 5, times the mass of the mouse, which is 3, divided by the distance between them squared, or 10 squared, plus the mass of the sausage, which is 2, times the mass of the mouse, which is again still 3, divided by the distance between them squared, which is also 10. And what I am going to get is 6.67 times 10 to the negative 11th times negative 15 over 100 plus 6 over 100. And if I multiply that out, and you guys can go ahead, pull your calculator out and do this with me, what you will find is you get negative 15 plus 6, which gives you negative 9. Divide that by 100, and you should get 0.09. Multiply that by 6.67 times 10 to the negative 11th, and you should get 6.7, or negative 6.7, excuse me, times 10 to the negative 13th newtons. So it's going to be a very weak force, and it is going to be pointing towards the heavier of my two objects. So guys, I just want to go ahead, I want to break down what I did to solve this, and I'm going to do that over here in blue. So first, draw your picture, and draw your free body diagram. So not just a picture, but also a picture of the forces and the direction in which they're acting. Then, list out your givens and unknowns as always before writing your F-net equation. And this is something you should be used to. You have to do this a lot in our forces unit, and I know it was hard, but I also know that you all know how to do it. It's going to just take a little practice to get back into the swing of things. And as you are doing that, pay attention to the direction of the forces in your picture. That is going to be very, very important. Finally, you're going to just expand out your force equations and solve for net force. So expand equation and solve. I'm going to make solve its own category, its own list. And now you guys are ready to go ahead and solve this kind of problem on your own. Good luck!